Hello again, Denzel here. So now we're going to be discussing our assignment number 2 of IoT. So just going to do a quick overview of what I'm going to cover. So we're just going to do a quick recap on what we did in the first assignment. I'm going to explain a little bit about MQTT, Node.js, and I'm going to do a quick demonstration at the end of the video. So a quick recap of what we had covered in our first assignment. We had discussed a little bit about I2C and how it works and everything. Also, the BLE, the Bluetooth Low Energy, and using our microbit to gather information such as the gap and the GAT of everything. Yeah, so this is just a general quick overview of what we've done in assignment 1. So now we're progressing further into working with the IoT with our device, which is the microbit. So what we're going to do in this second assignment will be updating all of the data from our microbit, such as our accelerometer values, if the button is being pressed, and also communicating back and forth from the gateway with the microbit. So for the communication, what we had used was our MQTT. There are quite a few different MQTTs out there, but the one we used was Hive over here. So just the first things first is the MQTT basically stands for the Message Queuing Telemetry Transport. It's a system where you can publish and subscribe messages as a client. It's a simple messaging protocol designed for constrained devices with low bandwidth and is perfect for IoT applications. And MQTT allows you to send commands to a control. It basically allows you to send commands to control, read, and publish data from the sensor nodes and much more. So next, just going to talk quickly about what we used was Node.js. So Node.js is a open source cross-platform runtime environment for developing server-side and network applications. It does have a few good features, such as the fact that it is asynchronous and event-driven, meaning that all of the APIs of Node.js libraries are asynchronous, and this is non-blocking, meaning everything can run at different times instead of being synchronous. And it's very fast in code and execution, and also there's no buffering, meaning that the Node.js applications never buffer any data at all. So the next piece of the code we are going to look at is our code. So now we're just going to take a quick look at our code that we wrote on our Node.js server here. So basically, the first thing we need to do, we have to be able to connect to our client with our MQTT. This will be the broker website and everything. So in order to connect to our client, you must be able to subscribe. So when you are subscribed, you are able to listen and see the messages being subscribed to the gateway. And when you publish, that is when the gateway communicates back to our device. So on our gateway here, we will see that this is the name of our subscribe button LED, and this is the name of the publish of the button here. So just looking at the code here, what we're going to do, this is the name of our microbit, and this is its address. So we're going to look at two characteristics, which is A00 and A012. This relates to the LED, and A012 relates to our accelerometer. So the way the code is edited here, there are a few functions that we need. For example, we need the actuator here, which relates to the LED. That gives us the function to be able to turn it on and off. We have a few more functions here in our code, such as the connect. So once we are connected to the broker, we will print this to our console. MQTT is connected, and then we publish that the LED is active, or more say we can publish that we are now connected. We will also see this on our broker here. Then once you are connected, we are able to send messages back and forth on our console. So we are able to print that messages have been received and all that kind of stuff here. But in order to communicate with our LED from the Hive MQ, we need a message event handler, which is what we have here. So just a quick overview of the code, how it runs down to it. Basically, if the message is on, we can then activate the LED, and if the message is off, we can then deactivate the LED. Yeah, so this function just basically allows us to control the messaging system. Just scrolling down here, we're able to, here we can scan to see if the state has changed from what we have been scanning. Also over here, looking for a particular part of our code. Yes, so over here, we can discover several different characteristics and services of the UUIDs. So for my piece of the code, I'm only going to discover two, which will be the LED and our accelerometer. So this piece of the code relates to our LED, and this piece of the code relates to our accelerometer. So once the code is run, it will then print everything in relation to the LED and the accelerometer on our HiveMQ. Yeah, so over here, the piece of the code here, this relates to our LED. So the LED, we can set an interval of 6 seconds to when it turns on and off, but more so here, I'm more interested in our accelerometer. So we can read in the values of our accelerometer, and we can update that every 4 seconds. It depends on how long you want that to be updating, but I chose 4 seconds, which is quite quick. From there, we're able to read and write data back and forth to the HiveMQ and also to our device, which is exactly what we need to do, and that is what we're aiming to do. Then over here, we can discover different type of callbacks. We want to discover 2, which was our LED and our accelerometer. We could have also done the same for our button. We can also activate our button. So once a button is pressed, we can publish that to our gateway and let the server know that button has been pressed. So finally, we're going to look at our demonstration of exactly what we have so far. So what we're going to do now, we're going to run our piece of code over here. So once the code is run, we do scan for our services and everything here. Okay. Then everything has been scanned. So our accelerometer values do change as we change that. So everything we view here, like I said, we are subscribed. So we are subscribed to our gateway over here. So like I said, every 4 seconds, the value does change of our accelerometer. As you can see, 1, 2, 3, 4, the values change again. I then move our device elsewhere just to show you, and we can see that it changes again. From the piece of the code, there is evidence that, like I said, we've subscribed to button and we publish to button LED. So now we are going to communicate from our gateway back to our device. So if I press on our gateway, we'll be able to activate an LED on a microbit. So you press on. When I press on, it then activates the same way. Like I said, if you press off, click there, it then deactivates. And simultaneously, when I press on again, it activates, but at the same time, the code is still running it's refreshing every 4 seconds, which is why Node.js is good. Like I said, it's asynchronous, which is good for us. So also, once we have everything running, once we do publish this, when we turn it on, the light does turn on and we see that a message has been received saying that the topic is on. Same goes for when we turn it off, message is off, LED is off.